Hello, everybody. Welcome to this presentation. Today we'll do a webinar on introducing the new illustrated libraries and the electrical catalog. I will be today presenting with my colleague Florence Berthold, as well as George Fatal. We'll be presenting different libraries, so everyone has their specialty. Also, if you have any question during the presentation, feel free to write them in the question section of the GoToWebinar, and somebody will answer you as fast as possible. We will start today, so let me just share you my screen. Okay, so first of all, what I wanted to tell you about is that we will start with the electrical catalog. Okay, for reason is that the catalogs has been available for educational institution for multiple years, but people may not know about them. So that's why we take this opportunity this morning to tell you about these catalogs. Right now, okay, first of all, this webinar will be recorded. So at the end of the presentation, you will all receive a link where you can actually rewatch this webinar or share it with colleagues. So being users of Automation Studio, this is the library that you guys are used to see with all the different modules that we have. And these components are generic components that you can bring on your schematic, start drawing, and you can double click on them to actually change the properties to make them fit your specific requirement. You see, if you click twice on it, we can go in the data and change the properties, okay? But a lot of our industrial customers were kind of like saying that it's too long for them because they're designing system. They want to be able to actually pull out components which have pre-entered information to start building their schematic right away. So we've come up with these manufacturers catalog. So I'm just going to take you to our website and I'm going to show you where you can find these information. So if you go on famictech.com, okay, then we're going to go into the section here, product, manufacturers catalog. And here you have a list of manufacturers catalog that we have developed. And this is always in development. Okay, these catalogs are being developed every day, adding new components, adding new catalogs. So they are available to all our educational customers who have an active annual maintenance plan. Okay, so you see here is a list of the catalogs that you can download and have access to components from these manufacturers. Okay, for example, if you click on Eaton, we have 20 catalogs for Eaton. So it brings you down to the list where we have a list of the component that you will find in these catalogs. Okay. And then somebody's just saying that they cannot hear me, but I think it's probably, if you cannot hear me, please click on the audio tab, and then you can actually test some audio inputs and outputs to make sure that you can hear us well. But most of the people can hear us now, so I'm going to keep it going. So this is what you have available, and then all you need to do is you're going to need to register on our website, okay? And once you register on the Automation Studio website, you'll be able to go to the technical portal where you can actually download these catalogs. And this is what you will see basically. You'll see the manufacturer, the catalogs that they have, and then you can download one by one that you like, or you can also select a bunch of them and download them all at the same time. For example, you see if I go in the first page, these are the new catalogs. So as you can see, we keep them updated as we go. And you see the new one, Automation Studio Electrical at the bottom. This is the one we'll be presenting today. Okay, so if you want to have this catalog, this is where you'll go and you'll find it to be able to download it. Okay, so I'm going to take a second more just to show you how this works in Automation Studio. So once you've installed the catalog, it will be in this icon here, Catalog Manager. Once you click on this, you're going to have here a list of all the installed catalog that you have. I just installed a couple one this morning to show you how it works. For example, if I go to Eaton, you see we have all kinds of different valve. If I do a two-way valve, I go on a model, I can see a picture of these valves, and I can simply drag and drop this component directly on my screen like that, and this will have the behavior exactly like Eaton, the SV4-8-C valve. Okay, so this is what our initial customer likes about the Automation Studio, is because it's not just data, it's simulated parameters. So once you start simulation, you're gonna have the same flow loss, everything will be the same, okay? And also something very interesting, if I go, let's say, in a different catalog, let's go hydraulic here. If I go for a pump, let's take a directional valve here, you see there's another one. If I go to the documents, for almost each of every component in these catalogs, you can open a file in which we test. It's like a virtual bench test for us, okay? So once you open this file, you'll be able to simulate directly that particular component and with the customer, with the manufacturer's information, okay? So this is where you see you can take this component, you just connect it here, and then you can follow the instruction to test the component. And during the simulation, you see we'll follow exactly the actual flow rate and the pressure differential that is set here by the manufacturer. Okay, so I just wanted to give you a small introduction like that because a lot of our customers don't know we have these catalogs. So it's important for you to know how you can install it. And now my colleague Florence will actually show you the new electrical catalog, and then we'll move on after that to one of the illustrated libraries. So Florence, I'm just going to give you the make you the presenter.
Okay.
So
You should be able to hear me now and see my screen as well. So as Christian has presented, so we have now an electrical manufacturer catalog, which is divided in 3 parts. So we have some element in control with timers, sensor such as level sensor, flow sensor, such as those components, temperature sensor, proximity, pressure sensor, and we have also PLC from 2 different manufacturers, Allen Bradley and Siemens. Then we have also another folder which contains more power components such as AC/DC machines. We have some soft starts control. We have also VFD with a lot of different manufacturers such as Allen Bradley, Eaton, Omron, Schneider, Siemens, Danfoss, etc. And we have also some transformer. And the last folder that we have in this catalog is resistance, which are standardized. So it will be able, you are going to be able to use only standardized resistance on your project. In the same way, we have inductor, capacitor, and diode. Okay, so as Christian has presented you, we have in each for each component we have like a test bench and some document related to the manufacturer data sheet. So here, for instance, if I want to use my PowerFlex 4M, I can open my file, my test bench file, to see how I can simulate this particular VFD. So yeah, the file is opening right now. It takes some time because in electric technical we have a lot of component on the test bench, that's why. But don't worry, it's going to open. Okay, so here you can see that if I put that on the side, you can see that the test bench has some instruction to explain you how to use the VFD, and the VFD is already connected to different other component from the main library. Okay, so if I want to simply start the simulation and see how to use the VFD using the keypad here, I can just start the simulation, start the VFD, and then here now I can control either by using the arrow the frequency of the frequency, or I can simply write the frequency which one I want to use. If I stop the simulation here, I can also go inside the VFD and go to the data branch and go completely down. Here you are going to find different configuration of the VFD. So if I go here, I can see that in the VFD configuration, I can select the way I want to switch on my VFD. I can also decide how to control the frequency of the VFD. So for now, we selected the keypad the way I showed you on the simulation. Or I can also decide to use, for instance, a preset frequency. So by using that option, I have to make sure that I select like the preset frequencies are entered. So by default, we put like 0, 5, 10, and 20 Hertz. Obviously, you can decide your own preset frequency. Once that is done, I have to also make sure that in my input, I will have in my digital side that digital 1 and digital 2 inputs are also selected as a preset frequency inputs. So once that is done, I can close that window and start my simulation. So I'll close my circuit breaker, switch on my VFD, and here now I can play with my two contacts to select the frequencies that I've preset. So for instance, when I 1, I get a 20 Hertz. If I open this switch, I get only 10 Hertz, etc., etc. So that is to show you how to use a test bench. Now, if I want to create my own project, so let me close that project. Let me open a new project, and I will go on my catalog here. If now I select, for instance, another VFD and I want to configure it, so I just go on the icon here and I can now select which VFD for instance, from Danfoss I want. So here, for instance, I want to configure a 3-phase 380 48 volt VFD, and which is going to drive a 0.75 kilowatt machine. So I will just press OK, and then now I will just drag and drop this VFD off on my diagram. Okay. Now to complete the diagram, I will select a machine. So I will, for instance, use a 3-phase induction machine from Leroy Sommer. I will also configure it as, for instance, a 4-pole machine with also a 0.75 kilowatt connected in delta with a 380 volt connection. So I can just drag and drop it, and now I will simply look for I will just look for a power supply, and I will simply connect it and now also connect the machine. So as you see that I could very easily connect the different components from the catalog to my diagram. As you can see, my two different components have the part number of my manufacturer. So here now, if I start the simulation, I can start the simulation. Okay, start my VFD, and now I can play with my keypad. So that is the simple mode to use it. I will also add on my simulation, from my simulation tab, the measure of the frequency to show that the frequency which is sent by the VFD is actually the frequency which goes out of my VFD. Okay, so then I can also use it in a different mode. So let me just close that. I can go to my VFD parameter. As before, I can go completely down here and decide, okay, instead to use my frequency source as a keypad, I can say I will use it with my analog input 53, and then I have to make sure that my input analog 53 will be connected, for instance, on a current input, which is configured as a scale ratio of 2500 between the hertz and the amps. So now if I close that window, I can just simple connect a DC current source, for instance, like that. So which is going to be connected by the pin 51, which is the command, to the pin 53. Okay, and I will add a slider to be able to connect the slider to the source here. So here I will connect my source as a 0.20 amps, the way I decided to do it in my VFD. And here I will connect the minimum as a 0 and the maximum as a 20 amps, 20 milliamps. And then now I just have to connect each other. So I go to the variable manager of the AC of the current source and look for my variable here. And now if I start my simulation, start the VFD, and if I move the slider here, you can see that the slider gives the information to the current source, which gives the information like regarding to the current goes to the 53 pin. You can have the related frequency which is sent to the VFD to the machine. Okay. So that ends my presentation of the catalog, but don't hesitate if you have any question. I will be able to respond it in the question section. Thank you. Christian?
Okay, so thank you, Florence, for this presentation. And as Florence just told you, like if you have any questions at the end, please feel free to send us an email or contact your sales representative right away. Now, Florence, we're going to go to the next step, which is presenting the Renewable Energy Library.
Okay. So now the second topic will be to present a new library. So it's a custom library. So for that, I will first of all show you where you can find those libraries that we are going to present you. So you can go to the open library here, and then if you go to your program data, Farming Technology, Automation Studio libraries, here you are going to find different libraries which we are going to present you today. Not all of them, but only 3. But me, I'm going to focus on the Renewable Energy Library. So I will open it. Okay. So this library is divided in 4 parts, or let's say 3 parts, because 3 are quite the same. So first of all, we are going to have the environment and control folder, which give you the different generator and sensor for the environment variables such as temperature, wind, and irradiance. Then you are going to have a folder which is more mechanical elements, which is useful for connecting the wind turbines to the electric module. And then you have two folders, one for IEC and one for NEMA, which contain different electric components such as batteries, converter, protection such as circuit breaker and fuse. We have also DC machine and AC machine, some charger controls for solar and wind energy, and some measurement instruments. Okay, so to illustrate a bit this library, I will now open a project where you are going to be able to see the different component from the library. So if I go here, so this project show you how to present, for instance, for the student, the different the curve, the VI curve, depending of the irradiance of the sun. So right now, if I start the simulation, for instance, I'm running my simulation at 1000 watts per meter square. If I start the plot, sorry, I forgot to go back here and put it as a variable. And then if I start my simulation here, click here, you can see that automatically this this graph send a variable resistance, which allow me to plot the curve of the VI curve of the PV. Now, if I decide to change my irradiance and put it to 500 volts, I can click again here, and then you can see the new plot of the VI curve. So that shows you that the irradiance is very important, is a very important input of the PV. But we can also show you something a bit different, because on the PV, we have taken in account like the orientation of the solar related to the PV, and also the inclination of the and also the slope of the PV. So if I go back to my resistance here and just put a 10 volt, let's say a 20 ohms resistance. Here I will be able, by starting here, so let me put again 100 watt per meter. But here now, on clicking on the PV, I can, for instance, here increase the slope. So as you see, like more I increase the slope, less power is given from the PV, because the sun, okay, what I forgot to say is like the sun is coming at 90 degrees. So the angle of the sun comparing to 56 is smaller. So we have less power from the PV. If I go back to 0, and now if I go back to 0, for instance, now if I go to, for instance, 20 degree slope, and I turn also my PV, you can see that doesn't have an influence because my sun is at 0. But if I change here, you can see let me, it's more flat. Okay, because it's 90 degrees, I need to reduce and to show the consequences. You can see like now, if I reduce the azimuth, my power is decreasing. So by that, you can show to the student that the inclination, the location of the sun related to the PV is very important as well. Okay, so now let me show you another project where now we are able to manage a battery charging. So okay, if I go here and I go to Mppt Charger. So as I told you at the beginning, we have created some Mppt some controllers such as Mppt or PWM charger. So here by connecting the PV to this charger, includes Mppt algorithm to allow to the PV to work always at the maximum of its power according to the sun irradiance. And this charger also manage the battery and the charge and the loads current. So for instance, here what we can see is, let's say the battery charged at 50%, and then we connect the load and the battery is also charging. So the battery is charging. So the battery is used for also supplying the load. So we can see that the charging of the battery decrease until a certain point. After that, we need to charge the battery. So we charge the battery, and then the load, after a certain level, we need to disconnect the load to charge better the battery. So we charge, and we decrease also the load to be able to charge more and more. And then from here, from this point, now because the battery is very charged, we disconnect the charging. So we use now the battery to supply the load. So the battery decharge, and then after a certain point, we decide that okay, the battery has enough discharge. So now we need to charge it again. So we charge it again, etc., etc. So this component is already in the library to be able to control the energy flow from the battery and the DC and the load from the using also the PV system. So that is on the solar charge. Now we can also create a wind turbine project. So if I go here and open a wind turbine project, as we did for the previous, as we did for the solar system, we can simulate a powertrain from the wind turbine. So if I start the simulation here, so here the wind turbine doesn't work simply because under a certain amount of wind is not possible to the wind turbine to turn. So if now I increase a little bit my wind speed, you're going to see that the turbine started to turn. And by switching on the charge, like the load, you can see that the wind turbine through the machine supply the load. So here I can increase the wind, continue to increase the wind to increase the load, to increase the power that can give the wind turbine until a certain point where now there is too much wind. So when the wind is too high, the wind turbine also stop. It's like a cutoff. It's like the cutoff wind speed. So that is included in the wind turbine. So yeah, so that's it. So if you have any question about renewable energy library, don't hesitate to also ask a question.
So thank you, Florence, for this presentation. So now I will be going to the DC electrical presentation. So let me just share my screen. Hold on. Okay, so first of all, I wanted to say that what Florence presented, we already had it in the software, but it was again not really a visual for students because they were mainly symbols. So you see, we had those. If you go to power source in electrical and you go to photovoltaic, we had these components, which is not really like visual enough for students. Okay, same thing when we go to wind generator and things like that, set point devices. This is where we had those information here, but again, it's not really visual. So especially with the COVID situation that happened and we're still in a bit, people did not have access to their trainers anymore. They had to do everything online. So it was not always obvious for students to have a better understanding of how it's connected in real life, like the wiring diagram basically. So by adding these images, this is what we try to do, is to make it more appealing and more easy for the students to understand. Okay, so again, like Florent says, if you have any questions, please feel free to contact us and we'll be able to help you. So another library that was created was the DC Electrical Library. Okay. Again, all these components are already available in the software, but as graphical, as more symbols, I mean. So now with this library, we have different components that were created. So we have, for example, resistance, but these resistance now, they actually are color coded. So if you drag them on your schematic, you can actually see the color code for each of the different resistance. Okay, so this is something that it's more visual for students. And I mean, if you want to display the value of it, I'd be my guess, you just click twice on it, and you can decide to display the component name, and here's the name. But if you don't want to show the name, you just erase it. That's it. Okay. So we have these. We also have a potentiometer, so 1K, 10K, 5K, and 100K. We're going to have some push buttons. And all these components were also created to be inserted on a breadboard. Okay. So let me just go through them, and after I'm going to show you a bit what we mean by the breadboard. So some switches, toggle switch, slider switch, a buzzer, some LEDs, diodes. We also have a ceramic capacitor. Okay. So in Automation Studio, as you know, it's very easy to modify values because we mainly click on the component and we can just slide to change the value. So I had to create like a one that's variable. So for example, like this one here. So 0 to 1,000 nanofarad. So when you start simulation and you click on it, you can actually change up the value. Hold on, something. At least one free connector. Okay. So let me just check here. So you see, if I click, you see I can change the value like that. Instead of going in the library and changing back and forth the capacitor, I can actually do it one like that. Okay. So we also have the polarized capacitors. And same thing, we also created one that's variable, so you can click on it and just adjust it. We have photocells. We also have the breadboard, the 555 timer, and a battery and power supply that you can also use to control these different components. So these components can be inserted on a electrotechnical AC/DC circuits. Okay, so when you start the software by default, you have a regular diagram. So you need to click on document here and actually choose a new electrotechnical diagram. And from here, you can see AC/DC. Once you open this sheet, you'll be able to bring these components on. Okay. So you can just create a circuit like this if you want, and I can just take a battery like that. I can put a resistance. I can just connect these two together like this and actually run the simulation, and then take my my multimeter like this and do some measurements. Okay, that is as it is today, but again with more visual components like that. Okay, or you can use the breadboard. So to use the breadboard, basically, you're going to do a new project. And on this project here, you're going to have different templates, as you can see, standard, imperial, electrical, AC/DC. Then we have electrical breadboard. So if you select this, it's going to bring in a template with the breadboard on it. And this is automatically set. So when you actually create some lines or wiring, the line will be thicker, like the wire will be more visible, okay? And we have here some manipulation tips at the bottom to help you work with it. So this breadboard basically is AC/DC, okay? As you can see here, you can change the voltage once the simulation has started, okay? So for example, or you could just bring a battery if you want and connect the battery, it's up to you. And directly on this breadboard, as you can see, if I drag component out, they're already laid out to drop directly on connection point like that and to connect. So if I take a push button, for instance, I can take it like that and it automatically connects. If you do a wire, you see if I click here and I bring my, you see how thick the lines are? By default. Then you can click on the line, you can go to the edit here and change the color to red, for example. So you can put wires of all kinds of colors on your plotter, on your breadboard like that. And once you launch a simulation, if you want, you can actually use the multimeter, obviously, on that as well. But you can also visualize the port in simulation if you turn this on, or if you don't want to, you just leave it off. Okay. If you want to have AC, you can take it from AC. And you see here, I can click. I need 9 volt. There you go. You want 24 volt? Be my guest. So you can change very easily the voltage on the breadboard here. There's a manipulation tip that I need to tell you about because it's important. We're actually trying to improve to remove that. You see, Automation Studio is very easy to do drawing and connect components together because you have a snap. You see, when you get close to a connection port, you see it goes as a target. But that snap makes it that if you go on a resistance and you want to move it, you see the cursor goes to snap under the component. So that could be an issue. So when you want to move this around, you need to make sure you have this icon and you click the shift and then you can just drag it and connect it somewhere else. If you don't hold the shift, you're actually creating lines from the original point to where you're moving it, okay? So shift disconnect. And also, if you want, let's say I put this here, I can connect, let's say like this. So obviously all these are connected together and this too. But if you want, you can, let's say for example, if I connect this up here, I can right click on my line and do a direct wire to go like this also. Okay, so you can actually make different type of circuits like this. And we are also working on creating in future versions a flexible line, so you'll be able to have like more like realistic turn line or wire the way you want. Okay, so this is, let me just open a circuit that I did to show you a bit one that is in simulation like that. So let me go in electrical here, breadboard. It's just like a sunset alarm, so it's pretty basic, but just to show a circuit that's actually working. And please, these are first versions of these libraries. So it's important that you feel free to let us know if you want to add components, if some things you find are missing, or if there's something that you feel like it's behaving not the way it should. We really looking forward to getting your feedback to improving this library, adding components to it so it becomes something that it's used for everyone and has a lot more components to it also. So if I simulate this, okay, you see like right now it's dark. I can show, I like to show the dots well. And if I go down the morning, the sun, then my buzzer goes on. I don't know if you can hear it, but it's coming out of my speaker on my phone, my screen. So, and then if it's getting dark again, it just turns off. So this is actually just something like that, actually just dragging the wire, recoloring them, and using the different component from this library. You notice here we have a transistor, okay? These are new components that we've been just added, okay? So right now, they are not in the library that you'll have DC electrical. It's not there, okay? But we will create them very shortly. We will pre-create different models. Like this one is like a BC547. So they have different, like, because we don't want you to have to configure it, we'll pre-configure a bunch of them. And then we'll put that in the library, which we will post on our discussion forum. This is where you can actually go connect and download many of these libraries. Okay, so just let me just show you very quickly here on our website. If you go support and you go forum, you'll need first to register. But once you register, you go to the educational section, and here we have the file sharing portal. And you see your custom libraries. So all these libraries can be accessed from here, and we will put more. For example, we have one that we've created, like this one here. It's component from customers, like a Schneider overload. We have some relays, a timer like this. So we will upload as much, as far as we create some, we'll put them there, and then they're available for you to download and use in your own project, okay? Also from this forum, we have all the demonstration files, okay? For example, if you go to file sharing and you go to electrical, let's say if I want to do some renewable energy, you see here, if you click, well, we already have a couple of demonstration that are made that you can download and actually use with your students that is working right away, okay? And you see here, if you click here, you're going to download 5 demo files of the renewable energy. Okay, we have over 180 demo files on the forum, so please feel free to go, connect, register, and download these files. Okay, so this is for the DC electrical. Another library that we've created, let me just do a new project here. I'm going to take, again, the AC/DC, because now I'm going to show you one that was created for residential electricity. Okay. Again, with being from home, it's not always obvious for people to know how to, residential electricity is a lot of hands-on and connecting things together. So the wiring diagram is very important. So here, as you can see, we have, for example, some switches, 2-way, 3-way, 4-way, and a start-stop button. We have light bulbs, 40 watts, 60 watts, 100 watt. We have photosensors, 2 wires and 3 wires. We have some outlets. So we have one, let's say, with the broken tab and one without the broken tab. So it's important if you want to do, let's say, like the top sockets are connected with your switch and the bottom ones are just independent. Well, the students need to use a broken tab instead of this one to do the connection. And also we obviously have the GFI switch, which you can connect and you can test and reset as well, okay? So these are the components. We also have some testing elements. If you want to test that you have electricity, we have like a fan that you can connect your outlet, a tester, and also a short creator. Because on the GFI, if you create a short, you're going to jump the breaker, so you can test it with these instruments. Also some merits. When you do your wiring diagram, you can use these. Junction box. We have an electrical panel also with breakers, okay? So for example, if I just bring a panel like this, and I connect like a 15 amp breaker like this, and if I take a double breaker, well, if I start the simulation and I do the measurement, for example, you see that this one here actually provides 120 volt, but this one here, if I'm connected on both of its pin, I have my 208 volt, okay? And again, these are protected by breakers. So if you put more than 15 amp, you will actually open the breaker and disconnect your circuit, okay? So this is something that we also have. And we have doorbells, transformer, doorbell chime, some power source because we have 120 volt. In Quebec here, it's white wires and red wires when you're talking about 220 for heating in the house. So created something like that you can use. We also have a thermostat. The thermostat is actually working. So for example, if I just start simulation and I just, let's say, connect the continuity here, you see right now it's sending a signal because I want 20, it's 19 degree. If I go over 19 degree, it stops. And again, if I increase it above it, I'm going to launch it again. Okay, so I'm just recompiling the library here. So this is something, a component that's also available in the this library. And we have some heaters because it's important exactly if you want to show how much 500 watts versus 2000 watt heater will take current, we can have that. So instead of building something right now, it's going to take too much time. Let me open a couple of demo files. And each of these demos that I'm showing to you are actually available on the discussion forum. Okay. So if we go just something with basic, just like light bulbs, because we have a watt meter in Automation Studio, you can actually show how many watts, let's say, your different lights configurations are taken. Something like this, for example. And if I do the simulation, I can flip that switch. You see, I can see 180 watts because in parallel, this one takes only 15 watts. So you see here, my 40 watt really take 40 watts, 60 and 100. Okay, so this is just to show you how this is actually well done. So it really takes what it should. If we go, for example, just outlets and GFI, let me open one that has a bunch of them. This one, it's easier. It has lights, breakers, outlets, and also the door chime, for example. So this is a type of a circuit like that. So you see I have my three-way switch here. So if I start simulation, I don't need my multimeter. So here's my three-way switch. You see what I told you before about the GFI switch? You see now there's power. So if I turn my fan on, it works. But then if I click on test here, I just turn everything up. And if I reset, I energize back the system. Same thing here with the door chime, for example, my transformer. And if I click here, the front door and the rear door. Okay, so it's just good for students to actually see what they're doing. And then it's more like a visual instead of just being schematic all the time. Okay. One more I'm going to show you is actually the heater, the baseboard heater. This one here. Again, these demos are pre-made, but you can create the one that you want. Obviously, you know the students have a library, and then they connect what you want them to connect. So you see, we have same thing here. So if I simulate, we can see here that I'm taking this. This one is the one connected right now. It's taking for 1500 watts, 7.2 amp. If I connect this one now also, oh, I'm at 15 amp now, and then 3000 watt. If I also connect this one, I'm at 18 amp. So you see my 20. So if I put another one here and I go over 20 amp, it's just going to actually open up this. So for example, let's stop this, erase the this one, and let's copy another 1500 watt up here. Okay. So let me just bring that down here. Let me send that to back and just connect it. Okay, now it's connected. So if I simulate again, this one here, and if I go over, you see my breaker just tripped here. And if I try to put it back on, it's closing again because there's too much. If I unplug this and then I go back, now it's going to stay. Okay, so this is what you can do with those type of configuration. And the different libraries that we've been showing to you are actually working all together. Okay, for example here, just to show you something, I have one that is like a solar panel connected to a PVM and then providing electricity to my home, for example. Okay. It may not be the way you would do it, but I'm just trying to show you that this is something that we can do. So you see I have my solar panels that are connected. So when I start simulation, okay, the power of the air is actually supplying the battery. It's charging the battery at a certain rate. Then right now, even if I trigger this, there's no power provided to my load, because I define in the PVM that after 110 volt only, I will supply the current to the system. So you'll see that when here it's going to reach 110 volt, this will turn off the red light, and I'm actually going to have some power now to my elements. Okay, so it's going up now, 110, 1.2. Sorry, I could have maybe changed the property so it's going faster, but anyway. And here on the plotter, I can just go back and just see everything. So you see when I'm going to reach 110, you'll see that this will be able to work now because I have enough. You see, 19. So you see now I'm supplying this to the system, and it keeps charging because I set here that when it reaches 120, then I'm going to disconnect the power source coming in. But now if I open my light, you see, oh, it's still like charging a bit, but then if I go here and I just turn on the heater, now it's barely charging because I'm taking 500 watt now. But it's charging less faster because I'm draining it. If I turn it off, it's going to charge much faster again. So these are little things like that, but sometimes with more visual component like this, it's easier for students to understand what's going on. So you'll see when I reach 120, it's going to turn off here, and I will only be using the battery now. So you see this, it stopped now. So there's nothing supplied anymore. So when I just drain here, I'm draining the battery, which will drain much faster now because nothing is supplying to the battery anymore. Okay, so all these technologies can be combined together. So that is what I wanted to show you from my part. So now I'm going to pass the screen to my colleague George, who will actually present to you the PLC part that we've created. So George, you can share your screen.
Yes, Christian, thank you very much. Okay, I'm trying to see here. Okay. Hi, everybody. Well, if we continue with the libraries, like Christian said and Florence, whenever you want to add a real PLC to your electrical projects or electrical control, basically it's the same procedure. You go and select on the top here, you try to open the library, and you'll find them that all the libraries by default are all installed in C Program Data FEMIC Technology E70 Automatic Studio and the libraries. And then PLC is one of the library that we are providing in this new version of Automation Studio, and then you can open it. Well, it's already open, but anyway, once you open it, it just open you over here a whole bunch of visual PLCs, basically. So I opened here, we have a whole variety of them. And as we said, that this library is an ongoing library, for example, and all the PLC that we added here are based on requirement sent to us from other teachers and from different colleges and universities. So what you see over here, we have the Alan Bradleys, and then the library in this library, we're providing two sets of PLCs, the one that can go on standard diagram and electrotechnical diagram. And just to let you know, the difference between a standard diagram and electrotechnical diagram is in electrotechnical diagram, whenever you build the library for electrotechnical, you can, for example, drag and drop it, and then it you can just build in the diagram, measure currents and build AC/DC circuits the way that you want to show them for in electrical courses. However, for people only working hydraulics and they want to build electro-hydraulic, electro-pneumatic circuits, and they don't want to go through the details of building AC/DC circuit to control these diagrams, they have to drag the same PLC out of the standard diagram branch. So if we go here, this is a standard diagram. Can bring back over here another PLC over here. For example, this one is a Control Logics PLC. And you see everything here is prepared and to be wired as specified by the PLC catalogs. So you see over here in the Allen Bradleys, we have different models. Can just show you difference here. So you just drag and drop the PLC to the diagram. And you see here the details. This is a Micrologics PLC. So feel free to help us continue building this library to send us the PLCs that you're using in your labs so we can add onto it. So in case you don't find the PLC that you're working with. Well, if you want to work with Siemens, same thing, can come over here. We had a whole bunch of them. See, this is a 1200. Got here the 7200, smaller. So you see over here. And by the way, all the animations, like it will, like the LED will turn on and off in the simulation. So I'll show you examples later on where everything's working together. I don't know if you attended the webinar one, I already used some of them to show you the wiring, but I'm going to review them again with you now. So you see here, again, we get the logo. This is a modular PLC, by the way. We can build modular PLCs, so where we can add more modules to it. For example, logo is the one that we have now, but we can add on that. There is a whole bunch of for the different PLCs. So here, for example, the logo. Let's say if we work on, let me go here and then start. We got the Koyo, for example, Koyo. We got see, so this one is got this one here. Several models. We got the Eaton. You go here. Okay, and then the Omron. Oops, I'm coming lacking space here, but anyway, we can just move over here and continue with my Omron. So we got Omrons. The Mitsubishi and the LS Electric are ready, and they're going to be added very shortly. We already finished testing them, and then they will be available in the days to come in the library. So we got this is the Omron. Mitsubishi, now the branches are empty, but we're going to have them soon. By the way, in the same PLC's library over here, very soon we're going to have the same library, but where we're going to provide OPC connectivities of this component with real PLC. And in this mode, in this library, you'll be able to do your wiring in Automation Studio, and then if you have the same PLC hanging on in the lab, you'll be able to, let's say, write in your logic using the instruction set of the PLC with the tools, the programming tools of the manufacturer of your PLC, and then run the ladder in the PLC, the external PLC, and control your circuits in Automation Studio. So basically, let me show you one example where everything is wired over here. So if I, no, I'm gonna close something over here. Yeah, so you see over here, this is typically an exercise where, like I did some wiring, and where I'm just putting here 2-cylinder pneumatic cylinder to execute an A plus, B plus, 3-second A, B minus, and then this is the logic. This is a new library, by the way, we presented in the previous webinar, webinar 1. For people who did not attend webinar 1, you can still send us emails, and then we're going to send you, well, you're going to probably find them on the forum, on the portal, and then you can download and watch the webinar, the previous webinar, if you missed it. And this is basically shows the new library for Allen Bradley's, which is the Allen Bradley 500 and Allen Bradley 5000 for SLC 500 and Control Logic's PLC. So if I turn on this example here, so you see here it's the logic executing in the ladder over here is executing here. And then let's see if I'm concentrating on the PLC, you'll see that the PLC here is, get this thing open a little bit. Then here, turn on the button. So you see here the simulation just show you the LEDs that are interacting, and the PLC behaves as a real PLC so it's very user friendly to use to show students how everything is working in real life. So that's it for my presentation. Like basically, if that, like I said, we'll be very happy to add more of this PLC based on your requirements. So feel free to send us the model that you're using, so we'll be able to add onto our PLC library. I see already here a question. TI from Joe at Tunis. TIA portal, sorry, and simulated. So yeah, well, basically, you can use the TIA portal and then use Siemens PLC and external PLC to simulate electrical motor and pneumatic valve that was created inside Automation Studio. Absolutely. Okay, so Christian,
Thank you very much, George, for the presentation. If you want to download, just a little correction on what George mentioned at the beginning. The PLC library was not delivered with the latest version of Automation Studio automatically, I think, because it was not ready once the version was created. So you will have to download this library on our discussion forum, where we showed you at the beginning. And to tell you frankly, on the forum we'll be updating. Like George said, we're developing the LSCS and Mitsubishi. So as soon as they're ready, they will be uploaded on the discussion forum. So this is probably where you should go to get the latest of all that we do. So again, if there's any question, this is what we wanted to show you today. And please feel free to send an email to your representative if you want any additional information, or to sales@thermictech.com, and we'll be more than happy to respond to your needs, your questions. And so again, thanks a lot for being here this morning. And if you have any question, raise your hand and I'll be giving you the mic so you can actually ask your question live. So thanks again, everybody.